Alright, section 3.5. These are polygon angle sum theorems. So kind of the same idea as the triangle angle sum, but this has a little bit of a twist to it. Okay? Some definitions first. A polygon, it is a closed plane figure, so it's a flat figure, has at least 3 sides that are segments, but it has to be closed, so it can't be like this guy on the right where he's opened up. Sides intersect only at their endpoints, so you can't have anything that looks like this and call it a polygon. And no adjacent sides are collinear. Alright, so example 1, if you look at this shape, what shape is it? Count up the sides. 1, 2, 3, 4, 5, 6. It's a hexagon. Okay, I assume you guys know what these are. So you might want to pause the video now, go through and write down the ones you know, and then come back and do the ones you don't know. Alright, 3 sides. The triangle. 4 sides is a quadrilateral. There's a lot of different types of quadrilaterals, so there's squares and rectangles and trapezoids and that sort of thing, but they're all quadrilaterals. 5 is a pentagon, like the building in DC. 6 sides is a hexagon, we just did that one. 7 sides is a heptagon, or a septagon, sometimes you'll see that called. 8 sides, you should know from driver's ed, because you have to stop at these every time you get a chance. 9 sides, is not sure if you've heard that one before, but it's called a non-agon. 10 sides is a decagon. And then 12 sides is a dodecagon. Those I assume that you know what those are. Alright, convex versus concave. This is kind of a science term. You'll hear this in science a little bit with mirrors and whatnot. So a convex polygon has no diagonal with points outside the polygon. So if you start drawing diagonals, all of them are inside the shape. Okay? All diagonals are inside the shape. But if it's concave, there will be at least one diagonal that is outside the shape. So picture concave as it's caved in on one side, and convex has no cave-ins. Alright, so let's name this, and we're going to identify it as convex or concave. So we count up the sides first. We go 1, 2, 3, 4, 5, 6. So it's a hexagon. And it's concave because it caves in. Alright, a theorem that you're going to need, the Polygon angle sum theorem. The sum of the measures of an n-gon, n being the number of sides. So it depends on how many sides of the polygon you have, is n minus 2 times 180. So number of sides minus 2 times 180 gives you the sum. Now if you were going to find one angle there, you would divide by the number of sides, and that would give you each angle in the polygon. Alright, so measures of the angles of a 15-gon, you take number of sides minus 2 times 180. And you get 2,340 degrees. That's the sum. Okay, one angle, if I divide that by 15, I get 156. So one angle of the 15-gon would be 156. I believe it's called a pentadecagon. Alright, they tell you it's a pentagon. So we know if we take 5 minus 2 times 180, this pentagon has to add up to 540. Okay, and we need angle y. So we're going to start subtracting things off. We'll subtract 90 3 times, because we have a 90 and a 90 and a 90, and then we're going to subtract the 135, and there is 135 left. So angle y has to be 135. Alright, and our last theorem. The polygon exterior angle theorem. So just like triangles, polygons have exterior angles too because you can extend their sides out. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. Doesn't matter what shape it is. If you add up all the exterior angles, they all add up to 360. The angles on the inside is the n minus 2 times 180, but the angles on the outside add up to 360. Okay? So you got to know which way this goes.